Welcome, stargazers. Might you at any point trust it? Picture a heavenly event so enormous that it creates shaded areas on Earth apparent. Indeed, even without trying to hide, that is the scene we may be near the very edge of seeing in the Orion heavenly body. The star Betelgeuse is acting bafflingly, indicating a looming cosmic explosion blast that will illuminate our sky more than ever. Yet, when will Betelgeuse go supernova, and what will it look like? As indicated by researchers, what secrets could this heavenly event uncover? Join us as we plunge deep into the details of what's actually the deal with Betelgeuse and the effect it could have on Earth and maybe for the whole planetary group. Found roughly 650 light-years from Earth in the heavenly body Orion, Betelgeuse isn't simply any normal star, it's a red supergiant, perhaps one of the most luminous stars known to us, shining with a brilliance more than 100,000 times that of our Sun. However, why does this red monster matter to such an extent to us? Well, Betelgeuse stands out not just for its brilliance but also for its history and significance in human culture. Named after the Arabic expression, Yad al-Jawza, which means, the hand of Orion, Betelgeuse has been noticed and documented by ancient civilizations for hundreds of years. It has been a guide for explorers and a place of wonder for stargazers, with its rosy tint distinguishing it from other stars in the Orion heavenly body. Might you at any point imagine a solitary star predominating our whole solar system? To give some perspective on the sheer vastness of Betelgeuse, if it replaced our Sun, its edges would stretch out all the way to Jupiter. How could a solitary star at any point accomplish such epic extents? At 10 million years old, it's much younger than our 4.6 billion-year-old Sun. However, Betelgeuse's massive size means it consumes its materials at a much quicker speed, predicting a more limited life expectancy than that of other stars. Now, this heavenly behemoth, spreading over a volume sufficiently large to contain more than 1 million of our suns, is approaching the end of its life cycle. When stars of such size reach their twilight years, they don't simply disappear, they go out with a bang, a cosmic explosion blast that is beyond human comprehension in terms of its energy and brightness. Such an event could potentially outshine an entire galaxy, creating shaded areas of brilliance across immense cosmic distances. The last time Earth saw a cosmic explosion this nearby was in 1964, well before the advent of modern telescopes. This event, known as the Kepler supernova, was the last supernova to be observed in our Milky Way galaxy with the naked eye, remaining visible for over a year and a half. It was brighter than any other star in the night sky and even remained visible during the day for weeks. What secrets do these heavenly leftovers reveal to us? Ancient records from various human civilizations, including Chinese and European astronomers, reported the appearance of this new star. Interestingly, remnants of this explosion, as an expanding debris cloud, can still be observed today with modern telescopes, giving us insights into the violent ends of massive stars. Generally, supernovae have been intriguing witnesses on Earth. However, imagine for a moment a cosmic explosion so intense that it rivals the brightness of a full moon, casting shadows on Earth at night and being visible during daylight. The radiation from such an event could charge our atmosphere, potentially affecting satellite operations and even the climate. Betelgeuse, with its erratic dimming patterns, suggests it could be preparing for just such a magnificent display. Could we be on the verge of witnessing one of the universe's most dramatic events? Recently, astronomers have made a startling discovery. Between October 2019 and mid-2023, Betelgeuse underwent a remarkable change that drew the attention of astronomers and enthusiasts worldwide, known as the Great Dimming. The star's brightness, which had been stable for centuries, began to decline significantly. This sudden change was apparent to the point that even casual stargazers noticed it while comparing Betelgeuse to other stars in the Orion constellation. It implies that we're not just hundreds of years from witnessing its supernova, but perhaps merely decades or even less. By April 2023, cosmic observations reported that Betelgeuse had returned to its normal brightness levels, leading many to believe that the period of dimming had ended. In an astonishing turn, the following months saw Betelgeuse's brightness enhancing by a remarkable 50%. Such striking changes, while typical of variable stars, were unusual for a star like Betelgeuse, which had predominantly displayed predictable brightness cycles. The unexpected and dramatic surge in its brightness thrust the star back into the spotlight, sparking discussions about its future. However, what caused this sudden change in brightness? Why did Betelgeuse, one of the most recognizable stars in our night sky, suddenly throw a celestial curveball? Stars are not merely glowing points in our night sky, they are dynamic entities with life cycles, activities, and secrets of their own. For some celestial bodies, periodic brightness variations can be expected, similar to the rhythms of Earth's seasons. Throughout its lifetime, Betelgeuse maintained a relatively stable 400-day brightness cycle. However, with the Great Dimming, it seemed to defy its established behavior, challenging our understanding of the cosmic phenomena above. Now, you may be wondering, are we on the verge of a celestial revelation? While the specific reasons for Betelgeuse's abnormalities are still being investigated, a compelling hypothesis has emerged. This hypothesis, focusing on stellar activity and mass ejection, presents a fascinating scenario. Picture Betelgeuse as a massive stellar volcano, suddenly ejecting and expelling a vast amount of its matter into space. Previous observations from the Hubble Space Telescope revealed that Betelgeuse had recently expelled a substantial amount of its surface material into the cosmos. This ejection, a monumental event, was 400 billion times the mass typically released during similar solar phenomena, equivalent to several times the mass of our Moon. Such occurrences can result in the formation of a dense dust cloud around the star, impacting its apparent brightness and temporarily making it more challenging to observe. Then, as this dust began to disperse or was pushed away by the force of the star's radiation pressure, the veil lifted. This could explain its subsequent return to normal brightness levels. One way or another, these new events suggest a star that is not finished astounding us. Many theorize that Betelgeuse may be approaching the twilight of its life, a supernova event, a staggering explosion of energy that can dominate an entire galaxy in an instant. This phenomenon occurs when there is a sudden change in the star's core. Such changes can arise if a star accretes too much matter from a neighboring star, or in Betelgeuse's case, it could be from the exhaustion of its nuclear fuel, which causes its core to collapse, paving the way for a catastrophic breakdown. But what drives a massive star like Betelgeuse to its end? Born from the gravitational collapse of gas within molecular clouds, stars like Betelgeuse launch their journey by burning hydrogen in their cores. This initial stage, known as the main sequence phase, lasts for millions of years and forms the foundation of a star's life. As stars run nearly out of hydrogen, they evolve, adopting new energy sources. In the case of Betelgeuse, as the hydrogen dwindles, it begins to burn helium, leading to the formation of carbon and oxygen. This transition from the main sequence stage to the helium-burning stage is marked by the star's evolution into a red giant. With time, as helium consumption decreases, the star undergoes further evolution and transitions into other burning stages, each characterized by the fusion of progressively heavier elements. Greater the star, the faster these advances, given the tremendous gravitational tensions at play. Then comes the peak when iron begins shaping at the center. Dissimilar to lighter components, iron doesn't deliver energy at the point when combined, so the energy created isn't enough to oppose the star's own crushing gravity. The star inflates in size and makes a collapse, followed by a monstrous bounce-back impact, resulting in the unstable power of a cosmic explosion. So, is Betelgeuse near the very edge of a dangerous end or simply gnawing its time? Later research by Japan's Tohoku College proposes that the star may be in its carbon-consuming stage right now. Fellow scientist Haddock believes that the center could implode years and years after its carbon holds evaporate. However, not all researchers agree. Differentiating studies from Hungary's Konal Observatory guess that Betelgeuse is still in the prior helium-consuming stage. The one thing that researchers really do settle on, no matter what these discussions, is that Betelgeuse is scheduled to become the Milky Way's next cosmic explosion. Yet, pinning down the timing of this event remains a grandiose guessing game, with wagers running from only a few years to 100,000 years. Amid these logical discussions and hypotheses about Betelgeuse's fate, one truth remains unchallenged: the very nature of our perceptions when we look up at the brilliant span. There's a subtle oddity we frequently ignore. This mystery is rooted in the actual nature of time and light in our immense universe. Stars and celestial bodies are so far away that their light takes a tremendous amount of time to reach our eyes. For example, the speed of light, while being a staggering 186,000 miles per second, still has its limitations. Thus, the light from remote stars and galaxies takes its sweet time to cross the immeasurability of space before it graces our sight. Looking at Betelgeuse, you're in fact seeing a display from 650 years in the past. To put that in context, when this very light left on its journey toward Earth, the Renaissance was just unfolding, and adventurers like Marco Polo were transforming history. Each observation we make of Betelgeuse is like glancing through an enormous time capsule, granting us insights into its far-off past. And if for contention's purpose Betelgeuse had already detonated in a superb cosmic explosion, we'd remain absent for an additional 650 years. So, while we talk about and anticipate its impending cosmic explosion somewhere out in the immense universe, this fantastic event could have already unfurled. We're just waiting for it to cross existence until it reaches our eager telescopes. The new disclosures around Betelgeuse have led to intense conversations in the galactic community, with examinations being drawn to another hair-raising revelation from recently, SN 2023X. This recently observed cosmic explosion happening in a system adjoining the Milky Way helped many to remember the intriguing elements and erratic nature of the universe. SN 2023X was remarkable in its own right, found a few million light-years away. It showcased an intense display of brightness that immediately outshone its host galaxy. However, what made it especially intriguing to researchers and casual eyewitnesses alike was its uncanny likeness to what many foresee will be the destiny of Betelgeuse. The range, force, and repercussions of the blast offered an enticing glimpse into the cycles that these gigantic stars go through as they approach the finish of their life cycles. For some, SN 2023X served as a reminder of if and when Betelgeuse meets its explosive destiny. The arrangement of events might look like what was seen with SN 2023X. Furthermore, the association between these two celestial events highlights a broader theme about the interconnectedness of our universe. Whether it's an adjoining star like Betelgeuse or a far-off cosmic explosion, such as SN 2023X, these grandiose phenomena remind us of the dynamic and evolving nature of space. Beyond the tangible and scientific, the blast would have significant impacts on human culture. The sky, noticed and adored for centuries, would change, prompting reflections on temporariness, the immense scales of cosmic time, and our place in the universe. Such inestimable wonders remind us of the ephemerality of existence and our timeless mission to appreciate the extraordinary past. As we examine the likely cosmic explosion of Betelgeuse, it's critical to comprehend the broader ramifications of such inestimable events. Supernovae assume a critical role in the life cycle of the universe, acting as cosmic recycling centers. When massive stars detonate, they scatter heavy elements like carbon, oxygen, and iron into the interstellar medium. This material becomes the building blocks for new stars, planets, and even life itself. Without supernovae, the universe would lack the diverse chemical elements essential for the formation of Earth-like planets and organic compounds. The explosive nature of supernovae also influences their immediate cosmic neighborhoods. The shock waves produced can trigger the collapse of neighboring gas clouds, potentially leading to the birth of new stars. This interplay between death and rebirth highlights the dynamic nature of the universe, where destruction paves the way for fresh beginnings. Astrophysicists study these interactions to better grasp star formation and the evolution of galaxies over astronomical time. In addition to their role in star formation, supernovae also act as crucial markers in measuring the universe's expansion. The light emitted during a supernova can be incredibly bright, and because of its predictable luminosity, it can assist researchers in calculating distances in space. This method, known as standard candles, has been instrumental in our understanding of dark energy and the accelerating expansion of the universe. Additionally, Betelgeuse's looming transformation raises intriguing questions about its possible consequences for Earth. While it is located a safe distance away, researchers are well aware of the influence the cosmic explosion could have on our environment. The radiation emitted could affect the ozone layer, potentially increasing radiation exposure at the surface. Such changes could have serious repercussions for life on Earth. It's important to note that Betelgeuse's blast is not an imminent threat. As we look ahead, the investigation of Betelgeuse and similar stars can help us unlock the mysteries of celestial evolution. Observations from telescopes, both ground-based and in orbit, allow researchers to monitor these stars closely. Future missions, like those using the James Webb Space Telescope, may provide rare insights into Betelgeuse's behavior and its potential fate. In cultural terms, Betelgeuse has inspired countless stories, legends, and artistic portrayals. Its distinctive color and prominence in the night sky have made it a subject of interest since the dawn of time. Many cultures have woven Betelgeuse into their cosmologies, viewing it as a guide or a harbinger of change. As we stand on the brink of witnessing its cosmic explosion, we may be reminded not only of our place in the universe but also of the interconnected stories that bind humanity to the stars.